Now number 10 is a little bit trickier. It's saying log base 2 of x is always less than log base 3 of x for any value of x. Well, that is sometimes true. Let me show you why. I actually went through and graphed log base 2 of x and log base 3 of x. Now log base 3 of x is the thicker line, and log base 2 of x is the thinner line. Now you can see that log base 3 of x is bigger than log base 2 of x up until we get to where x is equal to 1. And then log base 3 of x is smaller and log base 2 of x is bigger. And right at x equals 1, they're equal to each other. Now why would that be? Well, think about it. Let's say that log base 2 of x is equal to a. And log base 2 of x, or of log base 3 of x is equal to b. Well, we could write these as 2 to the a is equal to x, and 3 to the b is equal to x. Well, we noticed in the graph that at x equals 1, when x equals 1, they're equal to each other. Well, that would be saying 2 to the a is equal to 1, and 3 to the b is equal to 1. Well, the only way that happens, the only way you can raise 2 to a power and have it equal 1, or raise 3 to the power and have it equal 1, is if both a and b are 0. So in that case, remember, our logs are our exponents. This log is equal to a, this log is equal to b. In that case, they have to be equal. When x is 0, when the x's are 0, so we're setting these, or sorry, when the x's are 1, both of our exponents have to be 0 and they'll be equal to each other. Now, what happens if the x is less than 1? Let's say that it's 1/2. Well, I'm going to have to raise 2 to a negative 1. 2 to the negative 1 would equal 1/2. What will I have to raise 3 to equal? So once again, this is when x is equal to 1/2. Let's see. Go ahead and trace. Make sure that I want to be on the log is equal to 3. So when x is equal to 0.5, my answer would be equal to a negative 0.63. So this one, it's a negative 1. This one's, it's a negative 0.63. So in this case, this is the larger number, because remember, these are negative numbers. So this would be the larger number. So if our x is less than 1, this holds true. But what if our x was larger than 1? So we'd have 2 to the a is equal to 4, and 3 to the b is equal to 4. Well, I'm going to have to raise 2 to a higher number to get it to equal 4, then I'm going to have to raise 3 to, because 3 is naturally a bigger number. 2 I'm going to have to raise to 2. 3 I'm going to have to raise to, let's see, when does it equal 4? When x equals 4, oh, it's outside my domain. Hold on. When x equals 4, y only has to equal 1.26. So in this case, y equals 1.26, and this is equal to 2. So when your x is greater than 1, log base 2 of x would be greater, because you're going to have to raise 2 to a bigger number than you're going to have to raise 3. So, summary there. Log base 2 of x will be less than log base 3 of x only when x is greater than 1. When it's equal to 1, they're going to be the same. They're both going to have to equal 0 because the exponents would have to be 0. When x is less than 1, log base 2 of x will be bigger. Finally, number 11. Log base b of b to the n is equal to n. That's always going to be true. It's kind of like what we dealt with over here. This is simply saying b raised to the nth power is equal to b to the n. If you were to rewrite this as an exponential equation, this is what you would get, and that is always true. B to the n is equal to b to the n.